Find the real solutions of the following equation. We have 5x cubed plus 8x squared minus 9x plus 2 equals 0. We want to solve this equation. This equation is a polynomial equation. And I'm going to start with noticing the degree of this polynomial. It has a degree 3. And because it has a degree 3, I know that it's going to have 3 solutions. And this is using the fundamental theorem of algebra. So having a degree polynomial of 3 means that we have 3 solutions, or 3 zeros of the function. I'm also going to be able to use the rational root test to find any possible rational zeros of the polynomial equation. So with the rational root test, I'm going to be looking at our leading coefficient of 5, and that's going to be the value of q, and our constant term, which is going to be p, and it's actually factors of these numbers are going to be p and q. So for p is going to be factors of 2, and factors of 2 are 2 and 1. Let's write them in order, 1 and 2, and it can be positive or negative. For q, we have a 5, and factors of 5 are going to be 1 and 5. And using the rational root test, our rational zeros must be of the form p over q. So I can take all the combinations of p over q to form these possible rational zeros. So that's going to be 1 over 1, 1 over 5, 2 over 1, and 2 over 5. And these can all be plus or minus. So our simplifying those, we have plus and minus 1, plus and minus 2, plus and minus 1/5, and plus and minus 2/5. So those are the possible real solutions or rational solutions to this polynomial equation. So I can test out which one of these is true using my calculator. So we can bring my calculator in. And in the y equals menu, I'll put our equation. 5x cubed plus 8x squared minus 9x plus 2. And I'm going to use the table to help me do this. You don't have to use the table, but that's what I like using. So if I go to the table settings, that's second window to the table settings, I want to make sure that my calculator is in ask mode. And then I'll go to the table and I'm going to select these values. That's 1 and -1, 2 and -2, 1/5 and -1/5, and 2/5 and -2/5. So looking over on the right-hand side, I'm looking for when this equals 0, and I only have one that equals 0, and that is a positive 2/5. So I've identified one of the zeros of this equation, one of the solutions or zeros of this equation. So we found that 2/5 is the only one that we have so far. So I'm going to reduce this down using synthetic division. So 2/5 is a solution I know. And I'm going to write down just the coefficients. I've got 5, 8, -9, and 2. We bring the first term down, and we multiply 2/5 times 5 to get 2. We're going to add these together to get 10, and we'll multiply 2/5 times 10 will give me 4. We'll add these together to get -5, multiply to get 2/5 times -5, we get -2, and then we get our remainder of 0. So we started off with a cube, and we reduced that by 1. So that means that this will represent 5x squared minus 10x minus 5. I'm sorry, that's a plus 10x. Okay, so I think maybe I want to go into a little bit more detail about this division that we've done, and we'll come back to finding the rest of the zeros in just a moment, the rest of the solutions in just a moment. So some people may not have seen synthetic division before, and you might be more comfortable with long division. So when you're doing long division, it's going to look a little bit different. Okay, so we identified this 2/5 here as our solution, as our 0. So if we have a 0 of 2/5, that means that we have a factor of x minus 2/5. And so I'm going to divide using long division, and I'm going to show you how they're very similar to each other. So when you're doing long division, you're going to divide by x minus 2/5 into 5x cubed plus 8x minus 9. Oops, this is a squared, minus 9x plus 2. So when you use long division instead of synthetic division, this is what it looks like. And you're going to start off trying to match this x with this 5x cubed. So you're going to multiply by 5x squared. So you multiply that 5x squared times the x, and you get 5x cubed. And you multiply that 5x squared by -2/5, and that's going to give you a -2x squared. But then when we do long division, we always have to change our signs before we combine these together. So we're going to do the opposite here. We're going to make this minus and this plus. So 5x cubed minus 5x cubed, those guys cancel each other out. 8x squared plus 2x squared gives me 10x squared. And then we bring down our next terms. So we bring down the minus 9x and the plus 2. Now we repeat that process over again. So now we're trying to match that x with 10x squared. So we think, what can I multiply by x to get 10x squared? And that's going to be a 10x. And we multiply that 10x times the x, and that's 10x squared. And we multiply that 10x by the negative 2/5, and that's going to give me a negative 4x. Then we have to change our signs. So this becomes minus and plus. So now we have a negative 5x, and we bring down the next term. We get the 10x squared and the negative 10x squared canceling each other out, so that's why that part's gone. Now we repeat that process over again, and now we're trying to match this part right here. X times what will give us negative 5x? That's going to be a negative 5. Negative 5 times x is a negative 5x. Negative 5 times negative 2/5 is a positive 2, and then we have to change our signs. So that's where we get our remainder of 0. So hopefully you can see that we got the same answer doing it with long division and doing it with synthetic division. But I'm going to kind of compare these two for you so you can kind of see why it works. So hopefully you noticed that what we got on the top here is exactly what I have written down here. If we only focus on the coefficients, you can see that that's where those answers come from. And the numbers that you get in this row right here, you can see them here, here, and here. So the synthetic division, what it does is it just kind of takes away all of those variables and only focuses on the coefficients. So just to go back to the synthetic division for a second, the process is that these coefficients come from here. The first one you always just carry down. Then you multiply these two numbers to create that one. Then you add these two numbers together to get this one. You multiply these two numbers to get that one. You add these two numbers to get this one. You multiply to get this one, and you add these two to get this one. And once you've done that process, the numbers that you get at the end, these are the coefficients that go on your polynomial. Okay, so now that we have emphasized the synthetic division and the long division, we're going to come back and see where we are with our problem. So we have this 5x cubed plus 8x squared minus 9x plus 2 equals 0. And using that rational zeros theorem, we were able to identify one rational zero, and then we did some long division, synthetic division, and we were able to reduce that down. So now I'm able to rewrite this polynomial as x minus 2/5 times 5x squared plus 10x minus 5 equals 0. And I know that I can solve every quadratic equation. If I can't solve it by factoring, I can always go to the quadratic formula. So I know I'm going to be able to find any other zeros that I have. So using this 5x squared plus 10x minus 5, I can start by factoring out a 5. I'll factor out a 5, and I'll be left with x squared plus 2x minus 1 equals 0. I don't think I'm going to be able to factor that anymore, so I'll use the quadratic formula with a equal 1, b equal 2, and c equal -1. And the quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. I have -2 plus or minus the square root of 2 squared minus 4 times 1 times -1 all over 2 times 1. We'll simplify to get -2 plus or minus the square root of 4, and this is plus 4 over 2. That's -2 plus or minus square root of 8 over 2. The square root of 8 can be simplified to be 2 square root of 2, and 2 goes into both of those to make it -1 plus or minus square root of 2. So now I've identified all of the zeros. Remember, we said that there would be 3. So we have 2/5 being one of them, -1 plus square root of 2 being the second one, and -1 minus square root of 2 being the third. So these are the zeros, or the solutions, of our polynomial equation, 5x cubed plus 8x squared minus 9x plus 2. Use the given 0 to find the remaining zeros of the function. We have the polynomial function h of x equals x to the 4th minus 18x cubed plus 78x squared plus 294x minus 3,355. And we're given that this polynomial has a 0 of 6 minus 5i, and we want to find those remaining zeros. So one of the things that I notice here is that I have a complex 0, a 0 with I in it. And there's a theorem called the conjugate pairs theorem. I think this is supposed to be a J here, not a G. So the conjugate pairs theorem deals with polynomial functions with real coefficients. So you'll notice here that we have a real number 1 as the coefficient, the real number 18, the real number 78, the real number 294, the real number 3,355. So all of the coefficients on this polynomial function are real numbers. So we are going to be able to use the conjugate pairs theorem. And the conjugate pairs theorem says if we have this complex root, this complex 0, we are going to have the conjugate of this also being a 0 of the polynomial. So the conjugate of that is going to be 6 plus 5i. So we've already identified one of the remaining zeros using that theorem. So what I'm going to do is I know that when I have a 0 of 6 minus 5i, that there will be a factor of x minus x minus 6 minus 5i. And since we have a 0 of 6 plus 5i, I will have a factor of x minus 6 plus 5i. I can multiply these two factors together and then use long division to reduce this polynomial down. So let's do that. Let's multiply x minus 6 minus 5i times x minus 6 plus 5i. If we multiply that together, I'll multiply these first two terms together. Those are the first. And I get x squared. And then I can multiply the outside two terms together. So this one is the outside and this one is the outside. If I multiply those together, I'll have minus x times 6 plus 5i. I can multiply the inside two terms together, so that's this one and this one. If I multiply those, I'll have minus x times 6 minus 5i. And I can multiply the last two terms together, that's these two. These two are the last. And that would give me a plus. Negative times negative is a plus. 6 minus 5i times 6 plus 5i. Alright, so I've got some simplifying to do. I'll use the distributive property here and here. And I need to multiply using that FOIL method again on that last part. So I have x squared minus 6x minus 5ix minus 6x plus 5ix. And we'll multiply these guys out. That is multiplying the first two together would give me 36. Multiplying the outside two together would give me 6 times 5i, and that is a 30i. Multiply the inside two together. That's a negative 5i times 6. That's a negative 30i. And then I'll multiply the last two together. And that's a negative 5i times a positive 5i. That's a negative 25i squared. So we have some more canceling and simplifying to do. For canceling, I have a negative 5ix and a positive 5ix. Those cancel. I have a positive 30i and a negative 30i. Those guys cancel. I know that I squared is the same thing as negative 1. So I'm going to be able to write this as x squared. I can combine these negative 6x's, that's a negative 12x. I've got a plus 36 and a plus 25. And that gives me x squared minus 12x plus 61. So what this does for me is it allows me to now reduce the polynomial by this factor of x squared minus 12x plus 61. And we're going to do that with long division. So I'm going to take this x squared minus 12x plus 61, and I'm going to divide it into x to the fourth minus 18x cubed plus 78x squared plus 294x minus 3,355. All right, so I start with this x squared, try to match those leading terms. X squared times x squared will give me x to the fourth. I'm going to multiply that x squared times all three of these terms and write it down here. So x squared times x squared is x to the fourth. X squared times negative 12x, that is a minus 12x cubed. X squared times 61, that is 61x squared. Then I need to change the signs, so this is a minus plus minus. X to the fourth minus x to the fourth is 0. Negative 18x cubed plus 12x cubed, that's a 6x cubed, and it should be negative. And 78 minus 61, let's see, that would be 17x squared, and that's a positive. I'll also go ahead and bring down my next terms. 294x minus 3,355. Now we repeat that process over again. So now I need to do the same thing with a negative 6x cubed. And I would multiply this x squared by a minus 6x. So negative 6x multiplied by x squared, that's a negative 6x cubed. Negative 6x times 12, that's going to be a 72 plus 72x squared. And I don't know in my head what 61 times 6 is. 366, so that's going to be a negative 366x. I need to change the signs. This becomes plus minus plus. Negative x cubed plus 6x cubed cancel each other out. And then we have 17 minus 72. We get a negative 55x squared. And we have 294 plus 366. That's 660x. And we'll bring down our next term. Okay, so now we need to repeat that process one more time, and we want to try to match it with the negative 55x squared. So times x squared would need to be a negative 55 to make that work. We have negative 55x squared and negative 55 times negative 12. We've got 660x, and that is a positive, and 55 times 61 will give me the 3,355, and that would be negative. We would change the signs, and all of these zero out now. We get a remainder of 0. So we were able to divide that out. So now we know, let me zoom out a little bit. Now we know that our fourth degree polynomial of x to the fourth minus 18x cubed plus 78x squared plus 294x minus 3,355 can factor into these two quadratics. This factors into x squared minus 12x plus 61 times x squared minus 6x minus 55. We already know the solutions to this one. That's where we got our zeros of 6 minus 5i and 6 plus 5i. And we need to now find the solutions to this quadratic. We can find the solution to every quadratic by the quadratic formula, but maybe we'll get lucky in this factors. So let's give it a try. So if I try to factor this, I get x and x. Factors of 55, I would try 5 and 11, with a negative on the 11 and a positive on the 5. And I can see that that will factor correctly. So I can get my remaining zeros by setting these factors equal to 0. That gives me a negative 5 and a positive 11. So we started off with this given 0. We used the conjugate pairs theorem to get this 0. And once we divided out that factor, we got the other two remaining zeros of 5 and 11. Use the given 0 to find the remaining zeros of the function. Our function is h of x equals 3x to the 5th plus 5x to the 4th plus 138x cubed plus 230x squared minus 441x minus 735. And we're given that this polynomial has a 0 of negative 7i. So the first thing I notice is the degree of this polynomial is 5, so it should have 5 zeros. We are given one of those zeros to be this complex number, negative 7i. So it makes me think maybe we'll use the conjugate pairs theorem. So I just need to check to make sure all of my coefficients are real numbers, and they are, so that means that the conjugate pairs theorem is valid. And we have a second 0 of a positive 7i. That's the conjugate of negative 7i. So because we have zeros of negative 7i and positive 7i, I know that this polynomial will have factors of x minus 7i and x plus 7i. So I'm going to multiply these together and try to reduce the polynomial that we have. So I'll multiply this out, and that gives x squared plus 7i minus 7i minus 49i squared. This is x squared. The plus 7i and minus 7i cancel. I squared is negative 1. So we have x squared plus 49. And I know that this factor of x squared plus 49 will divide into our polynomial, reducing it down for us. So I'm going to use long division. X squared plus 49 divided into that polynomial of 3x to the 5th plus 5x to the 4th plus 138x cubed plus 230x squared minus 441x minus 735. And I'm going to try to match the leading coefficient, or the leading term here, with the leading term here. So I can multiply 3x cubed by the x squared, and that would give me 3x to the 5th, and 3x cubed times 49 would give me, I think, 147. Let me check. 49 times 3 is 147. And let me write that 147 underneath the cube, 147x cubed. I'm doing that so I line up my like terms. So then I want to change the signs to subtract. The 3x to the fifth minus 3x to the fifth becomes 0. I will carry down this 5x to the fourth. And 147 minus 138 is 9, and I'll have a negative 9x squared here, and I'll carry down these terms. So then I repeat that process over again. So now I'm trying to match this 5x to the fourth. So I will multiply by 5x squared. 5x squared times x squared is 5x to the fourth. And 5x squared times 49 will be 245x squared. And I'm writing it under the x squared, so I have my like terms lined up. I'm going to change the signs. 5x to the fourth minus 5x to the fourth is 0. The next term comes down. Negative 245 plus 230 would be a negative 15x squared. And we'll carry down these terms, minus 441x minus 735. Now we repeat that process over again. So I'm trying to match this leading term, negative 9x squared. So I need to multiply by, I think I made a mistake there. So let me highlight my mistake and correct it for you guys. So right here, this was a cube, and I changed it to a square, so I need to change that back to a cube. And this is also a cube here. So I would multiply that by a 9x, negative 9x. So negative 9x times x squared would give me negative 9x cubed. Negative 9x times 49 would be a 441x, and that would be negative. I'll change the signs. Negative 9x cubed and 9x cubed will become 0. Carry down this next term, negative 15x squared. Negative 441x and 441x become 0, and I'll carry down this next term here. So repeat one more time. Now I'm trying to match this coefficient here, and I need to multiply by a negative 15. Negative 15x squared, and 49 times 15 will give me 735. That should be negative. We change the signs, and we get our remainder of 0 that we expected. Let me zoom out a little bit so you know where we are. So our polynomial, h of x, we can factor that using our two expressions here. That's x squared plus 49 and 3x cubed plus 5x squared minus 9x minus 15. And we want to try to see if we can break down that 3x cubed plus 5x squared minus 9x minus 15 more so we can find the other zeros. So let's focus in on that, the 3x cubed plus 5x squared minus 9x minus 15. So One of the techniques that I try with cubic polynomials like this is grouping. So I group two terms at a time together and factor the greatest common factor out of each group. So for the first group, the 3x cubed plus 5x squared, there's a common x squared that I can factor out. And that would give 3x plus 5. The second group, negative 9x minus 15, has a common 3. And I'll factor out a negative 3, and that'll be leaving me with 3x plus 5 as well. Now, if this grouping method is going to work, what's in the parentheses here should match each other, which it does, so that method is going to work. So we're going to factor out that common 3x plus 5 and be left with x squared minus 3. And I'm going to be able to set each of these factors equal to 0. And this will help me identify the remaining 3 zeros. So I subtract 5, that's 3x equals negative 5, divide by 3. Here I'm going to add 3 and get x squared equals 3. Square root both sides and get x equals plus and minus square root of 3. So we've got now all of our zeros, because this is a 5th degree polynomial, it has 5 zeros. The zeros are negative 7i, 7i, negative 5/3, and positive square root of 3 and negative square root of 3. Find and simplify the difference quotient, f of x plus h minus f of x over h, where h is not equal to 0. And the function we want to find the difference quotient for is f of x equals 8 over x. So we're going to find this difference quotient, which is f of x plus h minus f of x over h. So we're going to take this in stages. Let's start by finding f of x plus h. And the way that you find f of x plus h is by taking x plus h and you substitute it in for x. So that's going to be 8 over x plus h. So I'm going to highlight that part there. So then we're going to subtract f of x, and f of x was given to us, so we don't need to calculate it, we're just going to use it. We're going to subtract 8 over x, and that's this part right here of the difference quotient. And then we're going to divide by h. So we have found the difference quotient, but we want to simplify it. And the reason we want to simplify it is because here it says that h cannot be equal to 0. Eventually, we want to rewrite this so that we don't have that 0 in the denominator. So we have a couple different strategies that we can use to simplify this. One of them is clearing fractions. We get rid of the fractions in the problem. And another one is to find a common denominator. I typically use clearing fractions, so I thought this time I'd take a different approach and try to get a common denominator. So I have 8 over x plus h minus 8 over x over h, and I'm going to get a common denominator for these fractions in the numerator, and that common denominator would be x times x plus h. So I just took this denominator and multiplied it by this denominator to get the common denominator. So I want to be able to add those fractions together. So I need for both fractions to have that same denominator. So on this one, I'm going to multiply by x plus h over x plus h. And on this one over here, I'll multiply by x over x. So that means that we're going to get 8x over x times x plus h minus 8 times x plus h over x times x plus h, all over h. Now that I have a common denominator, I can combine those two fractions together. And that would be 8x minus 8 times x plus h over x times x plus h, all over h. Let's distribute this negative 8 to break up that parenthesis, and we have 8x minus 8x minus 8h over x times x plus h over h. And then we have the 8x and the negative 8x canceling each other out. So we have negative 8h over x times x plus h, all over h. And it still looks a little bit messy because we have a fraction inside of a fraction. We call this a complex fraction. So what I want to do is I want to change this fraction bar, and the operation for a fraction bar is division. So instead of writing it in this form with the fraction bar, I'm going to write it with that division bar. And when we do that, that would be negative 8h over x times x plus h divided by h. And when we divide fractions, we change it to multiplication by the reciprocal. So we would write negative 8h over x times x plus h times the reciprocal. The reciprocal of h is 1 over h. And finally, we are now able to cancel this h out of the denominator and write this as negative 8 over x times x plus h. So we have figured out the difference quotient for x plus h. So f of x plus h minus f of x over h is negative 8 over x times x plus h.
Thank you for checking out my videos. Have a great day.